Rounding is a fundamental mathematical skill used to simplify numbers while keeping their value close to the original. We round numbers for various reasons, such as making mental calculations easier, estimating, or presenting data in a more digestible way. In this video, we will explore how to round using different methods, including by place value and by significant figures.
Part 1. Rounding by place value.
First, let's review the names of some place values with this number. Moving left from the decimal point, we had the ones, followed by the tens, then the hundreds, then the thousands, and then the 10,000s and so on. Moving right from the decimal point, we the tenths, followed by the hundredths, and then the thousandths, and so on. When the decimal point is not seen, the number is a whole number. You can imagine the decimal point to be on the right of the last digit. Next, let's look at the core rules for rounding. Let's say we want to round this number to the nearest hundredths. Step 1. Identify the digit of focus. In this case, it is 6, since 6 is in the hundreds place. Step 2. Look at the digit right after the focus digit, that is 2. If this digit is 5 or greater, round the focus digit up by 1. If this digit is 4 or less, keep the focus digit the same. Since 2 is less than 4, the focus digit stays the same. Step 3. Keep the rounded digit and all digits on its left. Step 4a. This applies to cases where the rounded digit comes before the decimal point. Remaining digits before the decimal point become 0. All digits after the decimal point are dropped. So 1624.897 equals 1600 when rounded to the nearest hundredths. For the next example, let's just change the 2 to 5. We will also round this number to the nearest hundredths. As in the previous example, 6 is the digit of focus since it is in the hundreds place. For step 2, the digit to the right is now 5. Based on these rules, the focus digit increases by 1. Since 5 is 5 or more, subsequent steps are the same. Keep the rounded digit and all digits on its left. All digits between the rounded digit and the decimal point become 0. And drop all digits after the decimal point. So 1654.897 equals 1700 when rounded to the nearest hundredths. In the next example, we'll round this number to the nearest tenths. That makes 8 the focus digit. The digit on its right is 9, since 9 is 5 or greater. Add 1 to 8. As in the previous examples, keep the rounded digit and all digits on its left. Step 4a is not relevant since the rounded digit comes after the decimal point. Instead, we use step 4b and drop all digits after the rounded digit. So 1654.897 equals 1654.9 when rounded to the nearest tenths. Note that this is the same as rounding to one decimal place. Finally, we'll round this number to the nearest hundredths. That makes 9 the focus digit. The digit on its right is 7, since 7 is 5 or greater. Add 1 to 9. But 9 plus 1 equals 10, a 2-digit number. So we use the 2 digits in front of 7, and get 89 plus 1 equals 90. As in the previous examples, keep the rounded digits and all digits on their left. As in the previous example, step 4a is not relevant and we move on to step 4b, and drop all digits after the rounded digit. So 1654.897 equals 1654.90 when rounded to the nearest hundredths. Note that this is the same as rounding to 2 decimal places. Let's summarize what we've learned about rounding by place value. Step 1. Identify the focus digit, followed by step 2. Look at the digit to the right of the focus digit. Next, in step 3, keep rounded digit and all the digits on its left. You have to possible roots next. If the rounded digit comes before the decimal point, all remaining digits before the decimal point become 0, and drop all digits after the decimal point. If the rounded digit comes after the decimal point, drop all digits after the rounded digit.
Part 2. Rounding by significant figures.
Rounding by significant figures is a way of rounding to a specific level of precision. It's especially useful in science and engineering where measurements have varying degrees of accuracy. First up, what are significant figures? They are digits in a number that are considered reliable or important based on the precision of the measurement. For example, the actual value of pi has an infinite number of digits, but for practical purposes, it is usually rounded to 3.14, which has 3 significant figures. Significant figures are essential because numbers can be very big or very small. For instance, the diameter of the Sun is about 865,000 miles. If this is converted to kilometers and then rounded to 2 significant figures, you get 1 million for 100,000 kilometers. Using place value or decimal places can be an issue when units are involved. For example, the diameter of a red blood cell can be about 7.8 micrometers. That's 2 significant figures and 1 decimal place. But 7.8 micrometers is the same measure as 0.0078 millimeters. That's still 2 significant figures, but now it is for decimal places. However, in both cases, you recognize that 7 and 8 are the important, measured digits, regardless of the unit. This highlights why significant figures are the standard way to express a measurement's precision. So, let's look at some simple rules about counting significant figures. 1. Non-zero digits are always significant. For example, 345 has 3 significant figures. 2. Zeros between non-zero digits are always significant. For example, 3045 has 4 significant figures. 3. Leading zeros are never significant. For example, 0.005 has 1 significant figure. 4. Trailing zeros with decimal are always significant. For example, 345.00 has 5 significant figures. 5. Trailing zeros without decimal are not always significant. For example, 34,500 has either 3, 4, or 5 significant figures. This point will be more clearly illustrated in a later example. Next, we'll look at how to round to a specific number of significant figures. The process is similar to rounding by place value, but you need to count the significant figures to identify the focus digit. Note that the first non-zero digit is the first significant figure, and the focus digit corresponds to the ordinal position of the significant figure. So the focus digit is the first significant figure if you are rounding to 1 significant figure. It is the second significant figure if you are rounding to 2 significant figures. And it is the third significant figure if you are rounding to 3 significant figures, and so on. Now let's see how this unfolds in rounding pi. The first 10 digits of pi are shown here. To round pi to 3 significant figures, the focus digit is 4, since it is the third significant digit. Then we look right at the next digit, which is 1, and that's less than 5. So focus digit stays the same, and based on steps 3 and 4 billion, we get 3.14. To round pi to 4 significant figures, the focus digit is 1. Then we look right at the next digit, which is 5, and that's 5 or more, so focus digit increases by 1. And based on steps 3 and 4 billion again, we get 3.1 for 2. To round pi to 1 significant figure, the focus digit is 3. Then we look right at the next digit, which is 1, and that's less than 5, so focus digit stays the same. And based on steps 3 and 4a, we get 3. Very easy, right? Next up, let us look at 0.080975. To round it to 3 significant figures, the focus digit is 9. Then we look right at the next digit, which is 7, and that's more than 5. So focus digit increases by 1, and based on steps 3 and 4b, we get 0.0810. To round it to 2 significant figures, the focus digit is 0. Then we look right at the next digit, which is 9, and again that's more than 5. So focus digit increases by 1, and based on steps 3 and 4b, we get 0.081. See the difference in the results? The results may have the same value, but the 0 at the end of the first rounding tells us that a higher level of precision had been used. So if you see these food labels, which look almost identical, notice that one has 0 grams of trans fat, while the other has 0.0 grams. It means you can expect the package on the right to contain less trans fat than the other one. Now, let's change the number to 0.080475 and round it to 2 significant figures again. The focus digit is still 0, but when we look right at the next digit, it is 4, which is not 5 or more. So focus digit stays the same. And based on steps 3 and for B, we get 0.080. Interesting, but still easy, right? Next up, we explore rounding the number 30 for 1,499.5 to different number of significant figures. To round it to 3 significant figures, the focus digit is 4. Then we look right at the next digit, which is 9, and that's more than 5. So the focus digit increases by 1. And based on steps 3 and for B, we get 30 for 1,500. To round it to for significant figures, the focus digit is 9. Then we look right at the next digit, which is also 9, and that's more than 5. So the focus digit increases by 1, but adding 1 to 9 results in 10. This is similar to the case we dealt with earlier, remember? And based on steps 3 and for B, we again get 30 for 1,500. To round it to for significant figures, the focus digit is 9. Then we look right at the next digit, which is 5, and that's 5 or more. So the focus digit increases by 1, but again, adding 1 to 9 results in 10, as in the previous example. And based on steps 3 and for B, we again get 30 for 1,500. See the same result in these 3 roundings. That's the reason why we said earlier that 30 for 1,500 may be 3, or for significant figures. Not too difficult, is it?
Part 3. Practice and application.
Now it's time to put your skills to the test.
Practice 1. Rounding whole numbers and decimals by place value and decimal places. You are given 30 seconds. Pause the video if you need more time.
Here are the answers. Manage to get them right.
Practice 2. Rounding by significant figures. You are given 30 seconds. Pause the video if you need more time.
Here are the answers. Manage to get them right.
Scenario 1. Rounding by place value applied to grocery shopping. You're at the store, and a bag of apples costs $4.87. You want to estimate the cost to the nearest dollar before you get to the checkout. How much is the bag of apples rounded to the nearest dollar?
Here is the answer. Got it right?
Scenario 2. Rounding by place value applied to road trip. A road sign says the next city is 4,418 kilometers away. To share this information with your friends in a simpler way, you decide to round the distance to the nearest 100 kilometer. What is the rounded distance?
Here is the answer. Got it right?
Scenario 3. Rounding by place value applied to baking. A recipe calls for 1.25 cups of flour. Your measuring cup only has markings for tenths of a cup. What is the amount of flour rounded to the nearest tenth of a cup?
Here is the answer. Got it right?
Scenario 4. Rounding by place value applied to population data. The population of a town is 99,540 to people. A news report wants to state the population to the nearest thousand. What is the rounded population?
Here is the answer. Got it right?
Scenario 5. Rounding by place value applied to running time. A runner completes a race in 3.486 seconds. The official timer only records to the nearest hundredth of a second. What is the runner's time rounded to the nearest hundredths?
Here is the answer. Got it right?
Scenario 6. Rounding by significant figures applied to scientific measurement. A scientist measures the weight of a chemical to be 0.0782 grams. For a report, they need to round this measurement to two significant figures. What is the rounded weight?
Here is the answer. Got it right?
Scenario 7. Rounding by significant figures applied to astronomy. The distance from Earth to the Moon is approximately 384,400 kilometers. A textbook wants to round this number to three significant figures. What is the rounded distance?
Here is the answer. Got it right?
Scenario 8. Rounding by significant figures applied to engineering. An engineer calculates the length of a steel beam to be 4,688 meters. For a rough estimate, they need to round this to two significant figures. What is the rounded length of the beam?
Here is the answer. Got it right?
Scenario 9. Rounding by significant figures applied to manufacturing. A manufacturer needs to cut a metal rod to a length of 2.495 meters. For quality control, they can only be precise to three significant figures. What is the rounded length?
Here is the answer. Got it right?
Scenario 10. Rounding by significant figures applied to financial report. A company's annual revenue is $12,450,000. To make the number easier to understand in a presentation, it is rounded to one significant figure. What is the rounded revenue?
Here is the answer. Got it right? For further practice or test your mastery, go to https://gemini.google.com/app. At the prompt, type in your request. Be very specific in your request. For example, you can ask, create a diagnostic quiz to test my ability to round off by place value, by decimal places and by significant figures. Wait for Gemini to generate the quiz for you. Note that Gemini will not respond to your inputs while it's still generating the quiz. You know that is happening when you see the number of questions still changing. When Gemini is done with creating your quiz, you can start inputting your answers. When your answer is wrong, Gemini will explain to you why you are wrong, and give you the correct answer, and tell you why it's the correct answer. When your answer is right, Gemini will also explain to you why you are right, just in case you were only guessing the correct option. Continue doing the quiz. Try your best to be honest in your response, so that Gemini can make an accurate analysis of your understanding. If you really have no idea what to do, either make a clever guess, or skip the question by clicking next without selecting any option. When you are done, Gemini will give you an analysis of your performance. Based on your inputs, it tells you what your probable strengths are, and what your probable areas of weakness are, and offer you further help in the form of study guides, flashcards, and further practice on everything or on just your areas of weakness. You can also ask for the quiz to be simpler or more challenging. Take your pick. All these are available free of charge.
Have